Well, good afternoon, guys. If you could just put your microphones on mute, please. Lamar, thank you. If you guys have questions, just unmute yourself and go ahead and ask. So, last class we talked a little bit about troubleshooting and just basic circuits. I apologize. One of my cameras had an error and it didn't record the audio to that video, so I didn't get a chance to upload it to the site because it was only recording audio from the computer, not audio from me talking, so the video was just, I'm sorry, it's wordless. So we'll continue on with the training though. This manual was given out 2 weeks ago, and we talked a little bit about certain things in this diagram. But now I want to get a little bit more deeper into the diagram and talk about certain components, how they work, and then how would we test them for troubleshooting something like this. So this is a whirlpool range. It could be a freestanding range or a slide-in range. This is a diagram. The manual that I have posted on the the manual that I had posted on the email for this class today has a link to the manual. MacArthur, you could mute yourself? Okay, thank you. This diagram came out of the manual. It was section 3, page 3, if you have copies of it, so you could see it better. But I will be going through the oven section of this unit and how it works, and this is the actual gas stove. So we're going to talk about the control board, the oven circuitry, how it works, and then how would we troubleshoot it. And we're also going to talk about the surface cooktop and how it works and how the control for that unit works. So let's start off with just something on the bottom of the diagram is something called a legend. Whenever you look at a wiring diagram, just glance at the legend all the time. Eventually, the more you look at it, the more you'll just identify components and lines drawn on the diagram. But they don't give you a lot of information on this one. They're saying component terminals. That's, basically they're talking about you have an open circle on this diagram. And again, this is a whirlpool diagram, so therefore you go to a Frigidaire or GE or other manufacturer, they might have slightly different symbols. But that means component terminals. That's where a wire would directly be plugged into something, whether it's a switch or a control board or a part in the machine. Where here you see they show a solid circle, and that's where wires are actually connected together. It'd be like 3 wires connected with a butt connector or some other connection there from the factory. This one here says no connection. You have to look at that like a bridge over the street. Like this is one street going north and south, and this is another road going east-west. Let's just say this is an expressway. An expressway has a bridge that goes over the other road that they don't intersect. I see a lot of people when they're tracing an electrical circuit and they see this, sometimes they go here and then they turn left. And an example, this would be like a freeway, but there's no exit on that street. So you're going over another street, but you can't get off and exit there. So that's what that symbol's meaning, is that if you're following this line going left to right, you stay on this line. If you're following the line going north to south, you stay on that line, but you cannot cross direction. Where here, with this connection, if I go down, I could go left or continue to go down, and that's what that dot means. Here, if you see a dotted or dashed line, that means that if this particular model had this feature, let's say a convection fan or something, this is how it would be connected. So the dotted line would still mean there's a wire, but if your stove that you're working on didn't have that part, you would just disregard that it was even there. So the reason why they do that is instead of making a wiring diagram for every model machine, they make one diagram that may fit 5 different models, and the difference is just one has convection or one has something else other than that. This is the first time I've ever seen, I'm sorry, I skipped the inline connection one. That's just a quick disconnect. That's like a plastic connector connecting 2 wires together. But going to here, This is the first time I've ever seen a manufacturer. They're identifying P1-2. You're going to see that on the wiring diagram, and they're telling you, well, P1 is the connector, and the number 2 after the dash is which one of those pins or wires on that plug is the one you're going to test. So at least we know P1 has at least 2 connections. It could have more, but that's what that is. And this one here is just irrelevant. So let's get into the wiring diagrams. I'm going to show just a minute or two about this video in a second, but I want to talk about this stove and so forth. So this here on the top is oven circuitry. We have the control board here, and I'll just highlight it for you. 1 second. So we got the control board here. This is just the main board, and I got some images of it. We're going to go through it. And this is all power going into the board and power going out the board. And the board has 2 main circuits. It has a 120 volt circuit because we have line 1 in neutral, because this is a gas stove. There's no 240 on this unit. And this first thing is power supply, and that would be 120 coming in, but the power supply usually contains a transformer which will step the voltage down for other circuits like our oven temperature sensor and let me see something here, our warming drawer sensor. It's even possible the door switch may be low voltage because there's no light bulb directly connected to the switch. The door switch is just connected to the board, telling the board whether the door is open or closed, maybe for self-clean, or even convection fans turn off when you open the door, and that's what that switch would tell the board. But it could just be low voltage, and that would usually be about 12 volts coming through here, where our sensors are usually running off of 5 volts. And both of them would probably be DC voltage, not AC voltage. And I've talked about that in my control boards. I don't really want to spend a lot of time on this upper circuit because I want to focus on everything below this line here, which is the cooktop and the oven circuit. This has something called a DSI board and a bake valve and a broil valve. So in this video I want to just show something because what happens in this video and how the burner lights is important to understand what's going on with the ignition of it, because it's used in both the oven circuit and the cooktop circuit on this stove. So let me go ahead and just play this video here real quick. Here on our display, so we rotate it till we see the word light line up with that line. Now I'm just waiting for the lighting of the gas burner. If I put the knob on there, I'm sending gas to the burner immediately, and I'm going to turn it to sparks. I want you guys to see, you're going to see sparks coming off of here like a little lightning bolt. So I apologize, I embedded this video. Let's see if I can make it bigger. There we go. So the gas is coming through the burner here, and it runs through something called a flash tube over to this white piece, which is your surface igniter. And that surface igniter, a spark, will jump off of here to this metal plate, which is ground. And ground is very important for these circuits to work. So one of the key things we need to know is ground. And I'll point out how and where that is important. But what I want you to watch is when I play the video again, what I want you to watch is I want you to watch the spark jumping from the electrode to the ground, and then it'll light gas. So when we turn the burner on, this is the main burner. There's a few holes here on the side of the burner which shoot gas through this flash tube towards the spark. Once the spark lights it, the flame will run back here and climb up a couple of other jet ports on this and then light our burner. So let's take a look and see how that works. Okay, you almost didn't see the very first spark. I can't even rewind it a little bit. This embedding doesn't work out for me. Next time I'll just play the video. But if you saw the spark jump from here, and then this goes out. Now in this particular unit, we have a surface igniter switch, which is what this box is, and I'll show you one up close and how it works. When I'm turning the dial, I'm doing two things. I'm turning the gas valve to let gas go to the burner through this tube right here called the venturi, and I'm also closing a switch here inside of this like tan colored box. Now at the beginning of the video I was pointing to a line on there, so when you turn the dial there's something on the knob that says light. You guys, after the class, if you want, this is on our public YouTube channel, you can check it out, and I go a little bit more detail of how it works, and I even explain how to check gas pressures on this unit. So the spark in that surface ignition switch, once it's lit, I turn the dial back to the high setting or low or whatever the temperature I want, and the switch inside there will open and it will stop sparking. That is not how the surface on this stove and this stove works. It has sparking in the surface of the stove just like this one, but it doesn't use the surface igniter switch that's in the front of the stove, and I'm going to show you those parts in a minute. But I do want to point out, if we look right here, this and this is a representation of our electrodes where the spark comes off. This is the ones on the top of the stove, and looking at this one here, there's 5 electrodes right there, and this particular stove possibly has 5 burners. I did not look at it closely. Let me just see. This drawing has 4, but the service manual that I sent you is for multiple units. So anyways, these are the electrodes, and if you look in the oven, most ovens, if you've done gas before, use what we call glow ignition. It's a bar that glows bright orange, and when it gets hot enough, the gas comes out and it lights. Well, this particular oven uses a spark igniter or electrode just like the cooktop, but it's run off of a separate control board called DSI. That stands for direct spark ignition, and basically all that is the same as the surface igniter, but this one is used mainly to control the oven, where we have a separate one controlling the cooktop. Over here, those 4 switches that I pointed out to you in the video, in this case here we have 1, 2, 3, 4, 5 switches. They all, if you look, doesn't matter what switch you pick. If I pick this switch, the power goes the same to our spark module there. So this module doesn't care whether you say, oh, I want the left front burner on, I want the right front burner on. It's going to spark every electrode on the top of the stove when this turns on. It's not going to turn on what you would say, well, if I'm turning on the 3rd one here, then this 3rd one here must be the one that's going to spark. No, they all spark. So the first thing we want to look at is, if 4 of them are sparking and 1 is not, it's most likely not the module itself. It could be, but I'll show you how to check that out, and how do we determine whether it is our switch, our board, or our surface igniter. Do you guys have any questions yet before I go on to the next portion of it? No? Okay, let's go to the next step. So I broke down the circuitry a little bit. This is all that we're going to talk about today. And over here on the right, I separated just the cooktop circuit all by itself. So when you're looking at this, you have to be able to identify specific, oops, my drawing is not too good. Let me try that again. So you have to go down here, through the module, and out to neutral. That's how current's flowing through that switch and that spark module. So if you look here, I just simplified it and removed the oven circuitry out of there. So when you're looking at a diagram, one of the first things you want to be able to see is the actual circuit for that, let's say, component that we're trying to troubleshoot. If the customer calls you out and says one of the burners on the top of their stove are not working, then this is the only circuit you have to worry about in that entire diagram. And so let's take a look at the components, and then we'll talk about how they work, and then we'll get into troubleshooting, and then we'll get to the oven circuit. So I screenshot the video. I apologize. I tried to enhance it a little bit, but you can see here there's 4 on this one. This isn't the exact stove in the diagram, but we got 1, 2, 3, 4 surface igniter switches. And if you see, when you order this particular one, they're daisy chained together. They're all connected together, so you replace all of them at one time. You can't replace just one. But if you look here, here's an image of a single one. 1 second here. I didn't want to grab that. So here's an image of a single surface igniter switch. Here's where the shaft of the gas valve, this shaft right here, slides on this. So when I'm turning the shaft of the gas valve, gas comes in through here and goes out there, the back, to the burner. So when I'm turning it, just like a hose, you turn the valve on the wall and water comes out the hose. If I turn the shaft, gas is going to come in and go out here. But I'm also going to be turning this little plastic piece here. So this is sitting on that shaft, and these 2 screws are important because there's 2 holes, and I think it's on the other side of the switch, not on this side. There's 2 holes, usually like one here and one here, that fit over the screw. So when you're turning the dial, this switch does not turn. The screws keep it from rotating as you're rotating your dial. So if you look here, I said the gas comes in where this screw is, and let me zoom in on that valve for 1 second. So you see a screw here, and you say, well, how's gas coming in through this? What you don't see is there's a hole probably on the back or on the other side of this tube, and it goes inside this square pipe here. We call it a manifold. So the valve you can see on this manifold is on the bottom, and this piece is inside that tube, and this screw goes on the top and screws it together. One of the important things you got to pay attention to is look at this gasket on the valve, and also notice there's a gasket on that screw. So we have a gasket underneath this screw, underneath this screw, and we have a gasket underneath this one. And yeah, we have one here too. This is how gas gets to the oven on this particular one. So gas comes in from the house into this tube. We call this a manifold, and it supplies gas to every one of these valves. And when we turn this valve, gas shoots out the back here to the burner, and this switch here will be sitting on the face of that unit. So let's go look at the diagram again. So when power comes in here, it just goes to line 1 and neutral on the module, and it has 5 output wires. Those are wires sending power out, which is a very high voltage, low current spark that jumps off of here. And notice that it goes to ground. I said ground is a very important part of this circuit. What they do not show in this diagram is that this module itself, let me use a different color. This module itself has to be attached to ground as well. That will complete the circuit for those spark igniters, electrodes. So here is the spark module. This is the spark module here. These 2 lines here are my line 1 and neutral coming in, and then these lines here are my 5 wires coming out, and they plug to the electrode on the bottom here, and then there's just a metal plate on the top, and a spark jumps through the air to ground. Okay, so this module, when you send 120 volts here, line 1, and I'll mark it line 1 and neutral. Oops, I'm sorry, my handwriting is not doing very good today with this mouse. So you got line 1 and neutral here. That's these 2 terminals. Once you put power here, it doesn't matter which knob you're turning, all of them are going to spark at the same time. So you're going to get a spark off of all of them at the same time. Okay? Now, here's some important things. Let's say a customer calls you out and one of those burners are not lighting. All the others are lighting. What does that tell you about your spark module? Anybody know?
My spark mode is okay, working.
Yes, it is working, but let's just say this one's not working and these are working. They're all going to ground, but you look and you don't see any spark coming off that one. So what we know, if any of them spark, I know I'm getting power coming into that module. I don't even need to check 120 volts coming in because I see spark at the other electrodes. I don't have to check power here. I only have to check power here if one or two things happen. If I turn on any one of those surface units and none of them are sparking, I could have either a bad surface switch, which is one of these here, you can see them here. One of them may not be closing and send power to the module, or the actual module may have a fault in it, and I'll show you why when I show you the oven board, because it's exposed and you can see how it works. But inside here we have 1, 2, 3, 4, 5. You can see how it's curved back there. They have some really big capacitors built up in there, and those capacitors store a charge. I don't know if you've ever worked on something that had like a motor with a capacitor or a microwave, and you discharge the capacitor, you see a little spark jump. That's basically what's happening here, is the capacitors are building up an electrical charge and they're discharging through this electrode. Now, I forgot to say, this here is usually ceramic. Sometimes you might see them plastic, but why do you think we have this big long piece right here? Anybody have any idea? That white piece around the electrode? It's like a spark plug, basically. It doesn't do anything. All it is a place for you to connect a wire, and there's just a piece of metal running through there. There's nothing happening in there. It's not a part that actually moves or functions. It's the electrical charge comes off of here, runs up through the metal, and then jumps to ground. Well, if this plastic was cracked, remember we had to jump to ground in that video. I don't think I have an image of it now, sorry. Let me see if I can go back to it for a second. Here on our display, so when we rotate it till we see the word light line up with that line. That's how we know when to light the burner. So, I put the knob on there. I'm sending gas to the burner immediately, and I'm going to turn it to sparks. I want you guys to see, you're going to see sparks coming off of here like a little lightning bolt. Okay, so I'll show it again in a second so you can see the spark for those of you who didn't see it when I played it before. But the distance from the tip of this electrode to ground is important, okay? Some of these burners are individual burners and each one has its own spark electrode. If this spark is not jumping right in front of, let's just say it's right here on the top of the stove, if the spark doesn't jump right in front of the gas opening, that spark goes someplace else here to ground, it'll never light the burner. So if you don't see a spark coming off the tip, this electrode could be cracked or broken, because if it's cracked right here, and let me go back to the image of, oops, I didn't mean to minimize that one. 1 second, please. If the tip of the electrode here is cracked right here, the distance from here to the bracket, which is ground, is closer than the tip here, and air, the bolt has to jump through air, which is resistance. If it's longer here than it is here, for example, the spark won't come off the tip. Okay, so that could also stop one of your burners from working. So let's talk a little bit about troubleshooting. We go there, and I know there's only 4 and we got 5, but let's just assume this one has 4 holes. And this one's not working. The module could be bad, or the electrode could be bad. Now, I have seen the wire also bad, and I'll get back to that in a second. So how do I determine if this electrode is the problem or my spark module is the problem? It's quite simple, but you might not think about it. Anybody got any ideas? It's like, okay, I see the 3 are sparking, but that second one from the left is not sparking. How do I know if it's the module? Because the capacitor could be bad in the module on just that one, or how do I know it's the electrode? Just switch the wires here. Let's just say this one went to this electrode and this one's not working. Unplug this one and this one was working. Switch these 2 wires. If this one starts working now, that tells you your electrode's good and your module's bad. So you don't have to do any tests with the meter or anything else. It's just a visual inspection of it. Just swap the lead from the electrode that's not working to the point where it is working, and if it starts sparking, then you know your electrode's good, and the reason why it's not sparking here is the module's bad. I need a new module. If I move it over here and put the good one over there, and now the good one's not working, but this one is, then I know that my module's bad. No matter what I plug in here, it doesn't spark, then my module's bad. So you can easily determine whether it's the electrode or the module just by swapping them. You don't have to put a meter here. If all of them are working except for one, then you know you got power here as well. Now, if all of them do not spark, one of the things you want to do is check to make sure you have 120 volts coming in here. If you don't have 120 volts coming in here, then the problem's going to be one of these switches are bad, and that's not sending power to that module to make it work. Now give me 1 second. I want to get a closer image. I don't see, but usually on the back side of here, the screw, there's a metal plate running to the back of this module, and I wanted to show it to you because that's how this is grounded. And it's important to know, I'm sorry, I didn't think about that until right now, so I really want to get a good image here. I'll bring this over so you guys can see what I'm doing. So I searched for a spark module. I want to get some images and see, oh great, this is perfect. This is exactly what I want to see. Now if you see this spark module, remember I told you the curved portions are where the capacitors are. You guys can see this? No? Let me copy and bring it into the presentation. I apologize. Oops. So if you look here at this module, these 2 terminals where 110 volt comes into this one, and this is where your 4 burners are connected to the unit. So this one probably uses this cap, this one uses this one, this one uses this one, and this one uses this one. But look at this hole right here. You have like a little copper looking circle. That's where the screw is that grounds it. And the reason why I wanted to point it out to you is, let's just say, oh, I think my module's bad. I got another module. Let me just plug the wires in and test it. If you do not screw, and I think there's another one here on the other side, if you do not screw it to the machine and make a good ground here, the electrode won't spark. And you also risk shocking yourself if you're holding it in your hand. So we do not want to energize this unless it's mounted inside the stove and properly grounded, or otherwise it will not function. I've had people, they took it off to test it and they had it hanging by the wires and they're trying to light the stove, and it's not working because they didn't have it screwed down with the ground, or they screwed into the plastic here but not to the one that actually had that ground ring on it. They screwed it to the wrong piece on the module. So you have to pay attention to that, but that's only happens if someone replaced it or you're replacing it, it's not working. So we get a spark coming off of here, it lights and lights the burner. So the cooktop is not that difficult, and troubleshooting it out is quite simple on a cooktop like this. So you know, if one is not working, just swap it with one that is and see if it starts working. Then you know, okay, it's the module or not, or it's the electrode. Any questions on that? Okay, so let's take a look at the oven circuit. The oven circuit brings a lot more components into play, and I have pictures of them, so we're going to take a look at them. So let's start off here with this box right here. I cut it off so I could remove some of the other stuff that might, you know, I cannot draw lines today. So we'll just not draw that. So this piece here is the bottom half of the oven control board. This is the one where you're going to say bake 350, and I want to bake, and a relay on that board is going to close and energize and send power to the DSI board. So the current comes in here from the plug, goes into the unit. When this relay closes, I gotta figure out a way to do this. I had a pad that was better. I'm gonna order a new one. So when this comes down here, it goes into the DSI board there, sending line 1, and this is neutral coming out. So the DSI board has wires of line 1 and neutral that we can test if neither the bake or the broil is working. Now on most gas stoves they use a glow igniter and a safety valve. This one here uses a spark igniter like the cooktop of the stove, and you can see them here, one for the broil and one for the bake, and this represents the electrode and ground here, and that's what that is. Those parts, again, if broil works and bake don't work, let's just swap these two wires if we can. I don't know if they're on a quick disconnect or individual wires, but if we were able to swap them and now that part is working, then we know it's our board is the problem. If we swap them and it's still not providing a spark to light the stove, then our electrode may be bad. So what does this do? This switch closes when you press bake. A relay on the board closes, sends power to the DSI board. The DSI board goes here to neutral. A capacitor stores a charge, goes through here and comes back out. So this is the valve and this is the electrode. But what happens if it don't light? What happens once it lights? Does it continue to spark after the burner's on? Does it spark all the time? No, it doesn't. So let's take a look at what it says about the DSI direct spark ignition. So it controls ignition of gas in modern ovens. Its minimum job is to ensure safe and reliable burner ignition while preventing raw gas from building up inside the oven. So this board has a safety circuit built in that if for some reason it does not light, it will stop the gas from coming out. How it works: sparking. The board sends a high voltage spark to the igniter. This spark should ignite the gas at the burner. Flame sensing. The igniter also as a flame sensor, and this is how this works. Once gas ignites, the flame produces a small electrical current. This current is sent back to the board as proof of flame. So what happens is, once the spark is here and it lights the gas, the flame here is going to send a signal through ground, and it's going to get picked up by the board here, and it's going to say, okay, we have ignition, stop sparking and leave this valve open. I'm sorry, I'm doing the broil igniter and the bake valve, but sorry for that. But if the spark ignites and the valve doesn't light or let the gas out to the burner, after so much time, the module will say, hey, I never saw a pilot flame here. Shut the gas valve off. At that point, we'll probably get an error code. If you look in the book manual, that they have different error codes in them that you could look up and see, oh, the problem's a module, the problem's something else. So let's look at the parts. So we have two different boards here. Someone tell me what is the main difference between these two boards. Both of them are DSI boards, by the way. Any idea? Looks like.
Is it because you got like four relays or four capacitors on?
Those are capacitors. Yeah, we have 4 on one and 2 on the other. Why do you think one has 2 more than the other? Just, it's nothing big, but the idea is I want people, when they're looking at a board and identifying certain parts of the board, know, oh, I know what that does. I know what that does. I'll give you guys the answer. This one is for a single oven with a bake and a broil. And this one here is for a double oven. Bake and broil in the upper oven, bake and broil in the lower oven. We may have a double wall oven that has 2 separate ovens. So this board is broken up into 2 separate circuits. We have bake and broil on the top and bake and broil on the bottom. So that's the difference between the two. And let's just take a little bit closer look at the igniter. So this is the electrode that I know they call it igniter, but igniter is usually a glowing igniter. This will still ignite the flame too. But again, here is the gap to ground, and this must be secured to ground properly in order for that circuit to work. So when you turn it on, and we'll complete the circuit as I'm going to put them all together. When you turn it on, voltage is going to come to this board and tell the board which one of these capacitors to try to light, and light the burner. Okay, a spark jumps across here, and then a flame comes off the burner and fills that void with the flame, and that's how the board knows, hey, I see there's a flame now, we can stop sending a spark to the unit. And here is the oven valve, and I have 2 different images of it to explain some of the parts for you, so we know what each part is, and then we'll break it down. I think I have the main control board also. So looking at this valve here, we have 2 solenoid operated valves. If we go back to the diagram, how much voltage are going to those valves?
Is it 120?
I don't think so. I'll have to look at the circuit, because usually if it was 120 volts, the other side of this valve would go to neutral directly. If you notice, the valve has power coming in and going back out. It must have its own voltage. It could be 12 volts. I don't know. It would be safer having a lower voltage than having a high 120 volts there, but other valves have that kind of voltage as well. So I just want you to notice that if it doesn't go to neutral directly, it's not always going to be 120 volts. I'd have to look it up in the book. I didn't think to look at it as I brought up this question, but this is your bake and your broil solenoid here. And so this is a double valve. The bake one, I think, is the yellow one, and the purple one here is the broil. And this is why I showed this side of the valve. So gas comes in to the gas valve through this opening. So this is where the gas is coming in to the entire stove for the customer. And then it goes through this regulator, and that regulator will send gas out here. Now, gas also comes out here, and if you notice, this one's in line with this solenoid, and this one's like with this solenoid. So when the gas comes off of the regulator, if I open up the valve on the left, the yellow one, gas is going to come out, and this is what's going to go feed the bake burner inside the oven. Over here, there'd be a tube connected running up to the upper half of the oven, feeding the broil portion. So this ignition system, how often do you think this ignition system works on this oven? Does it just light the oven one time and then it never does it again? Anybody? No? Yes?
No.
So what do you think is happening?
Well, every time you turn it on, then you need the light, right? I mean, every time you turn on the boil or brake function, you'll be relighting it every time.
Yeah, but let's just say you light the oven. Okay, I'm in bake. I turn the bake on, and once the gas burner's lit, I don't need a spark to keep jumping anymore. So it senses the pilot. It stops sending a spark. But while the customer's cooking, do you think it'll ever turn back on again? This spark module? That's a trick question.
Oh, no, I don't think so.
Well, let me ask you a question.
Okay, so that I think I misheard your question. But okay.
Okay. Well, I didn't give enough detailed information to make it easy. When you put the oven on, the gas burner doesn't run all the time, does it? I put my oven at 350. That burner stays on the whole time? No, it'll cycle on and on.
Okay, yeah, that's right.
At temperature, right? So when you turn the oven on at 350 and the oven reaches 350 degrees, the control board thermistor, the oven sensor, is going to tell the board, hey, it's 350, shut off the gas. So the gas is going to shut off and the temperature is going to go down again. And then what happens? It's got to relight. So this spark module is constantly turning itself on and off. By the board relay is going to tell the DSI module, hey, we're at temperature, or the customer wants to turn it off, stop sending power to these components, and then it has to go through the whole cycle again to relight. The other thing is, I'm assuming it happens on electric stoves. When you do a bake in electric stoves, sometimes we use the broil. Like we have the bake come on, get bright red, and then we turn the bake off for a few seconds or for 20 seconds, and turn the broil on just for a little bit, and then turn it back off and turn the bake on. And we do that so we're creating more even heat in the oven. It's very possible that as this unit is heating up, it may turn on the bake and then turn the bake back off and turn the broil on for a little bit and cycle them back and forth. And that DSI board is controlling those two, but they fall back upon what? These relays on the main board. Okay? That if I close the bake relay, I tell the DSI board, hey, spark to bake, energize the bake valve. Okay, turn it off. Now I want to turn on the broil for a little bit, so I'll turn this one off and turn this one on. And now I switch to these two components by the DSI board, and it's being told by the main board what to do. So what I'm trying to point out is, if you have this oven not working, let's just say I put it on bake, and I don't see no spark. Where would you begin testing, and what would you look for? I guess the first test would be the DSI board. If I'm in bake, I want to go to J16 or J14. Ricky, if you can mute yourself for a sec. Thanks. So if I have 120 volts here and I said that this is power coming in and the gas is not working, I know my main control board is good. If I don't have 120 volts here when I'm in bake, I want to check to see if this relay is sending power out. So I can determine which board is working or not working by going to see if the main board is sending power to this board. At least I know, okay, my main control board's not my problem. I might have a DSI board problem, I have electrode problem or a valve problem, but now I know, hey, I got to go down to this area. This is where I got to check next. So now I want to see. No problem, Mark. So, anyways, if I did not see the bake come on, just like the gas cooktop, I could switch these two if they're individually wired. And if we looked at, I'm sorry, wrong way. We looked at this DSI board. They are individually wired. So one of these is for bake. Well, let's just do this one because this is the single oven. I don't want to get this one confused here. But this one here is for bake, and this one's here for broil. If I just unplug these two and swap them and see if the bake works, then if I do, what's wrong? My module, my DSI board is bad. So again, how do I check this? I want to check input power, which would be on this plug here, and if we go to the wiring diagram, power to this board is going to be on J14 and J110, and also 6 and 7. These two have power all the time, but I want to check here to see if this board is sending power to tell it which one to come on. So I want J16 to J14, and if we look at the plug here, let's just say 6 and 4. 1, 2, 3, 4, 5, 6 would be here. 1, 2, there's no pin here, but you still count the point. 2, 3, 4. That would be 4 and 6. And I want to see if I have 120 volts there. That's where I would test to see if the main board is sending power to the other board. I know it's hard to see, but watch when I have all these parts on one screen, and I'm going to connect them together to show you the circuit, but show you how it works on the original parts. So let's go here. Here's the main board. This is the power supply coming in. This section here, I don't know if it encompasses the whole thing, is low voltage. This is your oven sensors and components here. And this one here, I could not read the letter on it, so I'm not gonna state what it is until I determine what it is. But these are the relays here. We have a relay for a bake and a broil. We have a relay for the convection fan. We have a relay for the lock motor for self-clean. So that's what all these different relays are. But one of them is for bake and one's for broil. So power comes into the board, and then when you press bake, one of these relays will close and send power out to the valve. So let's look at this whole circuit as a whole. So power is going to come in, line 1 and neutral. I'll put black here and red. Yeah, it was red. I know it's usually mean line 2, but you can't see a white line. So let's just say 120 comes in there. That's coming from the wall. That's power feeding it. If your board lights up, you can see the clock. We know we have power into the board. We don't have to test it. We're using a lot of visual things to tell us where to go. And if I see the board working, I'm going to go ahead and do that. Where is that point on this board? It's higher up. You're not going to see that here. We have to go back to the main diagram. I'm sorry, go right back to it. Right here. And I'm looking right here at P61 and P69. These two are the main power coming into the board, and so if the board lights up, I know I got power here. So that's what I was pointing out on this board. Now, the board is going to tell, let me get to that screen. The board is going to tell that burner to come on. So we're going to come off of this board here, and where am I getting these wires here? So if you notice, this says P2 and also P2, but this is P4 and P4. Again, I cannot see the letters on there. Let's just say these two are P2 and this is P4 over here. I don't know which one of these plugs is which, but let's just assume that. So we got power coming in on P21 and P24, so we also have line 1 coming in on this plug here, and we also have line 1 coming into this plug here. That's these two black lines right here. Coming out the board, we have a red wire, and it's going to feed the DSI board. So this red wire is going to come in and go to the DSI board like this, and then we have a blue wire here coming off, and I'll just say the blue is coming off of here, and it's also going to the DSI board, and that would be the pin 6 and 7 on here, so they'd be right next to each other. Coming off that board, we're going to have a couple of things. We're going to have our electrodes and ground on this plug, and we're also going to have our 2 valves coming off this plug. So coming off this plug, we're going to have 2 of our electrodes, and I'm only going to do one of them, and I'll do it like in a different color. Is one of these pins are going to feed the electrode, like so. I'm sorry, it's over here. One of these is going to feed this electrode here, and the other one is going to go to the other electrode. So let's just say this is the bake one. There'll be another identical one for broil coming off of here. So when I turn this on, it sends voltage through the red one to here, and we're talking about this wire right here, to this board, and then we have to have a neutral in here, so we have a neutral in here somewhere, and I would check those 2 terminals to see if I have power coming from my board. Now that board's going to send power to the spark module. Once it will light, the gas valve would have a plug here going like this. We'd have 2 wires going to this. So here is the steps in which it operates. Turn this on, press 350, it sends voltage to this board. This creates a high voltage surge which goes to the electrode to light the gas, and then we have another set of wires here going to the valve to actually let the gas out. Once the gas is lit and it sees the gas is lit, a signal is sent back through this module from ground, which is another terminal here, and it says, oh, okay, the flame is lit, shut off. So the surface test of the module is very similar to the test in the oven. If one of them don't light and the other lights, we want to know, hey, do I have a spark here? What if the spark is working but no gas is lighting? Could it be?
Could I have a weak igniter?
Well, no, because the igniter itself is just a piece of metal. It could be a module. The capacitor is not sending a high voltage charge. A customer has an electrical problem in the house. They don't have 120. Maybe they have 90 volts. It may not. But the voltage coming off of here, remember, this is just a piece of metal inside of ceramic. So it doesn't raise or lower the spark. Whatever this sends is how much spark you're going to have. So if it's not hot enough to light, I would revert back to the DSI board because it's the one that determines how hot that spark is. So if it does not light, hey, what if no gas is coming out? We could have a bad gas valve, right? So now I want to check to see if I got voltage coming off the board to my bake valve. And you have to look into the manual to get that actual voltage reading because the diagram's not telling me it. And I'm assuming that valve is not getting 120 volts. If you guys want to give me 1 second, I'll see if I can find that. I have the manual open here, but I do have to get to the actual diagnostic portion of it. See here if I can find it. It's going to take me too long to find it. I don't want to have you guys sitting here waiting for me to search for it, but I was just trying to see if I could find the actual voltage applied to those valves. A lot of times it's printed on the valve and I could not find it. So anyways, I need to go to the manual to determine how much voltage is here. If I have voltage here and the broil's working, this valve's bad. You're not going to replace any parts of it. You're going to replace the entire valve. This is how it comes when you order it. If I don't have voltage here, but the broil's working, for example, and I see the spark working, then I have to replace my DSI board. Because if the spark's working, I know my main board is doing its job. It's telling this board to run, but it's not energizing the gas valve. So all I need to do is, if one of them don't work, bake or broil, I want to see spark. If I see spark and I don't see gas, I'm going to check the valve. If I do not have voltage, I change this board. If I have voltage, I change the valve. So this one tells this part to work, this part tells these two parts to work. One is gas coming out the tube, and two is the spark that energizes that unit. There is not a lot to test on here. Let's just take a look at this circuit here. I'm just going to go ahead and go through part of it. I'm feeding the broil now, right? So this is 120 volts coming in. The relay said, I want to broil. What's this black wire doing here on the bottom? That's power to the module all the time. It's just that the module, even if the customer is not using their stove, the DSI module, just like your main control board, they have power all the time. So it has a little processor on here. Let me just not draw my line so big, but right here, this little black piece that's on the bottom of the board, that's usually a ROM chip. ROM is read-only memory. They have them on your computers. That if you're watching me on a computer right now, you have chips like that on the main board in your computer. But that's where the manufacturer puts the program in the board. So when you're telling it to bake or broil, and you say, well, how does it know to send power to just the bake? Or how does it know to turn the bake off and turn the broil on? Well, the relay does it. No, really, the relay goes to this board, and then this processor says, oh, I see power coming into the board on this wire. I'm going to energize the broil valve and the broil igniter. So the processor chip on here is what's telling it to do that. So this board here, or this wire here to the board, is feeding power to the board, so it's always awake. It's always ready for you to do something. Instead of putting power here, it'd be like when you turn your computer on every time when you sit down, or you put your computer like in a sleep mode. If you turn it off, it takes longer for that board to run through its program to start running your computer. In this case here, by being powered here, it's always awake and it's always looking for a flame. And it's doing that for a safety purpose. What happens if this particular switch here closes, right, and the gas comes on? What if this switch opens back up, but the valve doesn't shut the gas off? It could be a bad valve, but what if the board didn't accept that the power stopped running here, so it's to turn off the broil? How do we put a safety back in there? Well, once I turn off this switch, and let me clear it up a little bit. Once I open this switch and power stops coming in here, but I always have power here and here, the board is actually using this wire as a signal. Like, oh, the main board told me I have to turn on the broil. And in that case, it's using this one to energize the broil valve. But let's just say this board says, oh, okay, the customer's done cooking, turn this off, and we stop having power here. Well, if the board here relied on that power and I turned off this here, the board itself would shut down. That's good. But what if for some reason something failed? The relay on this board stuck, or the DSI board failed to turn the valve off. Well, this one here is going to monitor to see that the flame went off as a safety. So that's the reason why we have power to this board all the time. If you turn the flame off and that flame does not extinguish itself, it will see it through the gas signal on the electrode to turn this off. Now, could the valve be stuck and stay open? Yes, but I mean, in all the years I've been doing this, I've never seen a gas valve in an oven stick in an open position. I've seen them not open, but I've never seen them where they didn't shut off the gas. Okay, so anybody have any questions on these components? If you're not familiar with direct spark ignition, I'm going to do a couple of videos more on some of the components here and the diagrams in the next few classes, and I'll just keep changing it, part 4, part 5, or whatever. Do any of you guys have any questions on any of these parts? All of this stuff is in the manual, but not these pictures of the parts. I found them on the internet and brought them in, but they are all the exact part that would be on this exact stove. I went by the model number on Service Matters to get the actual part numbers, and then I researched the part numbers online, and these were the images that I found. So these are the actual parts of this stove. So we have 2 gas valves here, 2 gas valves there, and a regulator which has no electrical parts inside of it. But other than that, we went on our hour today. Does anybody have any other questions, or want to see anything else more, like something you don't understand that would like me to enhance in the next class that I give, or answer your question now?
I don't think so.
Okay, but I'll be doing a few more of these. Just keep an eye out for the emails. All depending on how Brandon's schedule and my schedule is. One of us will be holding a class again in 2 weeks, and guys, just look out for those emails, and appreciate you coming out. Y'all have a great weekend.
You too. Thank you.
Bye-bye.